In this video, we will explore the way live logic captures and displays your signals. Live logic captures edges, not periodic samples. When an edge is detected, the new logic value is bundled up with the amount of time since the previous edge and stored in memory. The acquisition continues, waiting for and storing new edges until the number of edges requested by the user has been stored. Then the acquisition stops and is displayed. Live logic includes two acquisition modes, continuous and single. Continuous mode includes a timeout that keeps track of how long the acquisition has been running. The acquisition will terminate and a new acquisition will be started when the number of edges requested is satisfied or the acquisition timeout expires. This produces a display that is continuously updated even if the signal you are probing is static. In single mode, the acquisition timeout is disabled. Each acquisition runs until the number of requested edges is satisfied or you manually stop the acquisition. It is then displayed until you manually start another acquisition. This allows you to examine and analyze the waveform, decode its values, and save it for later reference. Live logic can capture long time spans up to 90 minutes in a single acquisition. This is possible because it only stores signal activity, not the spaces in between. If no edges are happening, very little memory is consumed. Live logic must store at least one sample every 2.7 seconds to avoid overflowing its timer. This is what limits the maximum acquisition time to 2.7 seconds times 2048 samples, or about 90 minutes. Here is an example of polling an I2C device once every 90 seconds. 35 sequential accesses were captured in a time spanning 50 minutes. Let's make a measurement using the A and B markers. Here we can see that the time of the acquisition is 31 seconds. If we zoom in a bit and set our markers between the two transactions, we can see that each transaction occurred separated by about 89 or 90 seconds. If we zoom in further on the actual transaction, we can see the contents of the I2C transaction. If I want to measure the start delay, then I can measure that with a resolution of 2.5 nanoseconds. In this case, the data line was asserted low 4.1 microseconds before the clock was asserted low.